So yeah, good morning everyone in Bangalore. Uh, so yeah, this is a topic that I'm gonna talk about. Uh, a little bit about me. My name is Aftab. I do DevOps things by day and organize meetups and speak at events like this by night. I also do a slight bit of stand-up comedy, which is basically the same thing. You uh, try to make people laugh by hoping they learn something new. So I started off as a 3D artist. Now I'm working as a DevOps engineer for over 2 years now. I know, a weird trajectory. So before we begin to point a few things, yes, this is a demo session, but uh, how many of you have worked with Grafana before? Okay, so it's gonna be a lot harder for me. This whole talk is gonna focus more into Grafana, and this is more like an intermediate topic, but since most of you are Grafana friendly, it would be more like a beginner session for you. Okay, so to set the context, we use these two terms interchanged, monitoring and observability. First thing is I want to differentiate both of this. Any Malayalis around here? Okay, that's amazing. So about monitoring is uh, it is clear now. Okay, this is better, I guess. So monitoring. So monitoring is basically gathering data, just like the picture shown in this, thing. Uh, it is like you look into something and you just know that something is happening, but you don't know why or what's the root cause of it. So that's what basically monitoring is. Then there is observability. Observability is, you can consider it more like as monitoring 2.0, but you know, when it comes to monitoring, you know that something's happening, but in the case of observability, you'll get to know why it's happening. So that's why the statement, it is taking the data collected and moving beyond what is happening to why it's happening. Now, when it comes to observability, there's a bunch of theory. I don't know why I added this. So there are like mostly 4 pillars of observability. I have added only 3 because I am lazy. We are IT folks. So yeah, metrics, traces, and logs. So metrics is numerical data which some of us cares about. Then there is logs, which most of us cares about because that is a particular sort of data that we all used to think, right? So I did have an interview, a few months back, and everything about troubleshooting. I mean, he asked me a lot of troubleshooting questions, and my every answer to the troubleshooting questions was check the logs. And he rephrased the question like, what if you don't get the logs? I asked him, you could add an IAM policy to generate logs. So that's what my answer is. So that's how important logs are. Then there is traces. When it comes to a microservice architecture, when many of the services are communicating with each other to, perform this whole big task, uh, with the help of traces, you will get to know where in this particular timeline it's slowing up. So this whole pillars of observability is collectively called as telemetry signals because we'll be talking more about that collectively. Now, we know what is observability, what is monitoring, and what telemetry signals are. So what's the problem? So imagine, how many of you here are more of a home lab guy like me, or is everyone using their cloud platforms? Okay, cloud platforms is it? Okay, so I'm a home lab guy, so the demo will be concentrated more of a home lab setup. Now, in the case of huge infrastructure, you have a bunch of what do you say, logs, traces, and telemetry signals coming from all sorts of things. So the problem here is you get a bunch of data, and when you check the logs, it will be more like this guy is doing this guy is doing this, and the server is still on fire. You don't know what's happening. And even for a powerful data visualization tool like Grafana or other data visualization tools out there, when you feed this much amount of data into to the data visualization tools, it usually gets stuck. I mean, it finds it harder to visualize it. So that's the problem. The incoming data is almost entirely noise. In other words, you could say it is not optimized. So that's a problem, right? Now, the solution that I'm trying to propose is this thing called observability pipeline. So what observability pipeline does is you collect all those data that is coming from XYZ sources. You collect it into a particular centralized thing, and you redirect it to multiple destinations as well. So what is the advantage here? Every data coming into the collectors, or this is the portion that I'm talking about, the collectors. It will filter out whatever that is needed and shows or routes only the important part towards the destination. So that's what this whole thing is called, an observability pipeline. Now, talking about the functionalities here, I know I have used a lot of Malayalam movie references here, just pardon me. So yeah, functionalities or features of observability pipeline is noise filtering, the exact thing that I mentioned before. There's this parsing. For example, if you take logs, for example, logs are parsed differently in different platforms. So you could configure your collector to get the logs and convert it into a into a more optimized way such that it is suitable for visualization. That's a feature. Then there's event tripping. When I mentioned about logs, I told you like this guy's doing this guy's doing this, and you don't need all those events to be visualized into your visualization tool, right? So you can just trim all those data and do it. Now, when it comes to trimming, you can, the end result of the whole logs, the total logs is reduced to an extent, right? So you can, expect low cost for, databases for that. Then finally, data condensation. This is actually something that happened to me recently. By recently, about a year ago, there was an intern in my company, and we were asking him to look into the logs and stuff. So somehow in those logs, the GitHub personal access token was shown there. So that is so bad, right? You shouldn't give off the GitHub access tokens like that. It's just an example. There are a lot of other things that could go wrong. So that is the functionalities of this. Now, okay, so I have told about observability pipelines and all. I hope the theory is fixed. Now, what does it look like in reality? So in this particular example, I have an EC2 instance running. Amazon users are there everywhere. So EC2 instance running. And using certain agents, I'm taking logs, metrics, and traces, and I'm pushing it to a vendor-neutral OpenTelemetry Collector from Grafana. It's called Alloy. It is launched recently. And this Alloy is going to filter data and send it to the Grafana dashboard. This is what we'll be doing. But we're not gonna complicate things, so we'll just consider this section, the metrics filtering part. So yeah. Okay, I can maybe show you how the Grafana Alloy is configured. So since, like I said, this is more like a home lab setup, I'm using Docker Compose for Prometheus, Grafana, and Alloy. There is a node exporter to export Linux metrics to um, Prometheus. And this is the Alloy configuration as of now. So what I'm doing is, this is a very trivial example, and this is a very simple example. You could expand on this. I'm going to drop all the metrics with the name node CPU seconds total, so that when it comes to the Grafana dashboard, you won't see these metrics at all. And I also want to replace this whole IP with the name Linux instance. So that's what I'm doing, and I'm routing it to Prometheus. This is the Alloy configuration for the thing. And what Alloy looks like, this is what Alloy looks like. And there are various components here, and in this relabel component, you can see the rules that I've mentioned. The changing the name and dropping the metrics. So if you go to live debugging, yeah. Okay, so there is a bunch of data coming in, obviously. So I'm just going to stop for now, and I'll just scroll up to show you what's actually happening here. Yeah, there's a lot to scroll. Okay, so as you can see, I hope everyone can see in the back as well. So this arrow says that, that is the converted version. Before the implies sign or the arrow, this is what Alloy gets. This is what Alloy gives. So here the instance is equal to the IP address and the port. And after conversion, it is mentioned instance is Linux instance. And I told you that we'll be dropping a metrics, right? So yeah, node CPU seconds total. This is what Alloy gets. And after transformation, it's just dropped. Nothing is going to come out. And I have an example dashboard here just to give you an idea of what it's doing. So here, all those data is not coming in. That is because the PromQL written here has node CPU seconds total. So that's exactly why it's happening. So yeah, so this is how, this is a basic example of how this can be done. And if you, it's just a screenshot of the same that I just showed. If you wish to try this yourself, based on your own caution, you could just scan this repo, and this repo does not only contain what I just showed. There is other scenarios as well. You could just try it out yourself, because the time restriction is that. If you have scanned, I can move on to the next slide. Okay, so that's basically it from my side. So the conclusion is, yeah, it is essential in a way when you put it that way. But for home labbers like me, I'm not sure if it is a requirement, because I'm not going to use observability pipeline to monitor my Windows machine or my Linux machine. But if you have a more sophisticated, infrastructure with you, considering an enterprise point of view, this can be a necessity. So otherwise it will be an overkill, but it's a good to have thing, but otherwise it's a necessity. So yeah, that's it from my side. Thanks a lot for listening.
Yeah, so questions, anyone? There's a mic up there, so feel free to line up and ask your questions. You will observe the mic. You will observe the mic. Yeah, you can go there. And yeah, it's for the record.
Hi, I'm Suman from Blinkit. So my question is this: let's say dropping the metrics and dropping the logs and all, it's there already. It's been there forever. The problem is what to drop. I'll tell you an example from the real experience. Let's say we actually have a custom metrics out of application. Let's say an application does some business logic. We actually export some business metrics out there. So sometimes they actually create a metric which is like high cardinality, right? How do we stop it well before it hits our storage? Otherwise, it's just gonna choke the entire storage. This is like, I'm guessing this is at runtime when we actually access it, not while we store it, is my guess. But like, how do we, is there a way to actually stop it before exploding and choking our storage?
Yeah, actually, so in this particular example, you could, you could configure Alloy, and there are other tools also out there, but this is open source. So there is Alloy. You can configure it to, store all those data into a database. And before storing it to the database, you can filter it out as well. So before reaching the database, you can filter everything from Alloy layer.
Right. My question was, is there a way to find if it's explosive? Like there are tons of labels in a given minute or some configuration like that.
As of now, I haven't explored much into it.